January 27th, Thursday, and we will wrap up Seaborn plotting today with notebook 15. So I'm just going to go through it. And when I hit, I've made a couple of edits to the one I've got um, that you can also make. So if I blast past something and you're getting a different result, and I can't quite remember what the old one was doing versus what these I made a couple of edits, two or three. Please feel free to slow me down and say I'm not getting that. I'm getting something else, and we can talk it over interactively. So notebook 15 would be a Chrome tab. I'll share my whole screen. And here we are. Introduction to Plotting Part 2. I believe the header of your file has an incorrect one where it says something about number 9. That's what it was last time. But this time, plotting with Matplotlib and pandas is in notebook 14, plotting with Python part 1. So all I did to modify that, it's a markdown cell, and you can tell that by looking up here in the cell type dropdown. It's a markdown cell. I double clicked on it, and that's like putting the cell in edit mode. So you can edit the text. You can see it automatically renders a bulletized list here, and then star is the bold. You put that on either ends of a string of characters, and it'll put it in bold. And there's I want to say there's a markdown cheat sheet that I've posted earlier in the course. Let's look. Could have swore. Yeah, there it is. Jupyter Notebook Markdown cheat sheet. So that tells you how the little commands and whatnot, like through these 3 pound signs, are my header. And to render that markdown, you just hit Control Enter. So just a brief reminder about markdown cells, and a brief reminder about plotting. Just because you can create a plot doesn't mean you need to create a plot. So there's lots of power in here, but it's easy to get noodled into eye candy just for eye candy's sake, if with any tool. So yeah, the underlying library of Seaborn is that Matplotlib, and I think we saw previously that there are some parameters, even if you're using Seaborn, there are some parameters that you are either modifying with Matplotlib, or you need to kind of know how Matplotlib works, because that's what you're sending the parameter to. Seaborn takes what you're sending it in a Seaborn command and turns around and calls Matplotlib. So sometimes you'll get a Matplotlib error, and you're like, but I'm using Seaborn. Well, that's why, because these libraries are all interwoven and using each other. So, all right, without further ado, cell number 1 imports Seaborn and PyPlot, Matplotlib PyPlot as PLT. So we'll execute that one. Oh, and we're reading in one of our many data sets. We'll get into that a little bit more when I go over my sample project. So we're bringing in tips, which is our restaurant tips data. And count plot is a pretty cool looking bar chart. Execute that, and you tell it the x-axis goes under here, and now you'll get a bar for each unique value in a categorical variable. So we're getting the basically the count. I mean, it's a count plot, so it goes in and counts the number of entries on a Thursday and the number of entries on a Friday, Saturday, and Sunday. So that's a nice little simple Seaborn plot that works with categorical data to kind of give you an idea of what you're doing. And again, the theme of today is exploratory data analysis, where we're looking into data and kind of just running some quick diagnostics and running um, some graphs to take a look at the data. And then you'll see in the exercise we're going to do, that's exactly what I did with a seaborne data set. Um, this next one, count plot, lets you add um, sort of like a second grouping variable. So again, we've got day just like before. We've got day on the x-axis, x equals day, but we have added this hue. In my lexicon, a hue is a color, but they tend to add it as a grouping variable or like a third variable in a, you got x and a y and then a hue. So that would just require some practice to kind of get used to it. But you could do these either way. So we could, this one repeats the exact same uh, counts as so these 60 um, total meals or whatever that were on a Thursday have now been broken down by male. I guess people that paid the check were male and yellow is female. You can set all those colors. You can set the tick marks. It's just, but this is the most simple rendering of that type of chart. But you can move these around, and I encourage goofing around with these things to kind of see. Um, so let's reverse that. So now we're seeing um, because sex is a categorical variable with only two values. Now we only have two sets of bar charts on the x-axis, where sex is now the x-axis, and now our hue uh, grouping variable I shifted it to day. So now you get them broken apart by days of the week. And they're in basically the same proportion. So I would, in an exploratory thing, I would say it's not like you can see a huge change in the ratio. Um, maybe on Saturday, the ratio is a little bit different, but I don't think so. Nothing to see here, I guess. But that's how you works. That's how the command works. So yeah, you just kind of dig into the documentation and look at how these different plots work. Now, yeah, I'll leave it like that for next time. So a scatter plot with regression line. Here is another seaborne plot, LM. I looked in the documentation, couldn't find it. So I think it's linear models seems to be what LM plot does, is like linear regression modeling. So you give it an X and a Y variable because it's a scatter plot. So it's looking at two variables and, drawing the scatter plot. And but then you can add a third variable with the hue um, uh, parameter. And you can add um, a column parameter that will give you multiple plots. And then of course we tell it what data we're using here. But execute that, I get a scatter plot. Like I was saying, the column equals time tells it we want to have a plot split horizontally by that categorical variable. If time only has two values, lunch and dinner. But if it had more, you'd have a separate plot for each one. The hue, notice here, just like we did in the previous plot, hue breaks up your X and your Y, tip and total bill. It's for both plots. It's total bill along the x-axis, predicting tip going up the y-axis. But hue equals smoker breaks it into these orange and blue dots so that you can kind of see the relationship of smokers versus non-smokers. So like you got an outlier in the right hand dinner time, you got a smoker that was apparently a big tipper. But it's kind of hard to tell any particular trending, I think, looking at this. But it's one way to do it. So you can compare and contrast multiple variables that way. Three. No, yeah, really four, really. By looking at multiple plots and the difference between them. Okay. So here's, I won't read it, but here's a thing to remember about Seaborn. And you'll see it in error messages sometimes, that you're calling the wrong figure level plot, you need an axis level plot. Or so the figure is the entire drawing, and these subplots are the axis level plots. And we'll get into that a little bit more in the bottom. So getting those two terms helps understand how Seaborn is working with these things. And I think we're going to wind up getting a couple of deprecated functionality messages here pretty quick. So here we're going to do a histogram without the smooth line over the top. And yeah, we get our deprecation message here. Seaborn is moving to displot with no T. So if I do that one, it seems like it's not quite the same. So you kind of got to get used to these new, and these libraries do this all the time. You see this quite often. Oh, it didn't like, yeah, there you go. Displot has different parameters. There's no set title. It does it in another way. So yeah, you got to now you got to hit the documentation. If you're updating your code, at least they warn you that in the future a method is no longer going to be supported, or it's going to act differently. But anyway, that's a histogram, and I put the KDE, which is that smooth line, kernel density estimate. I made it equal false. So we can put it in here, and it defaults to having the KDE. I don't think I even really needed this hist equals true on here, but it worked, and I didn't want to mess with it. So you can see here the set title lets you put a title above the graph, and we are sending the total bill field to a histogram, which gives us the distribution. So like I say, in this data is really skewed around like a $15 tab. A few bigger parties, but it looks like mostly just folks coming in for lunch. Okay, so that's a histogram with, and this, yeah, like I said, this KDE line just kind of shows you a little bit smoother distribution of the data. And then KDE plot only just gives you that smooth curve. And then a rug plot, and there's, like I said, there's that I posted the link to that Seaborn tutorial. It's cool just looking through just what you can do. I mean, you can go through all those notebooks in half an hour, and take a look at all those different charts, but there's virtually nothing you can't do with these libraries. So a rug plot adds, and again, we got a future warning, but rug plot adds these little tick marks at the bottom to show you the density of the data. And it's just another way of looking at it. The histogram, what do you call it? The histogram shows you the shape, but this one shows you kind of a little bit more of the density. But it's the same measure. I mean, it's just another way of looking at it. Although I guarantee you, some PhD got to name, I'm going to call this the rug plot, and he got his name written in the book somewhere for coming up with a new graph. Bivariate data. Yep, these are just looking at um, two different variables in subplots. So we're creating two matplotlib subplots here, called scatter and axis, and that just creates the object, right? Scatter and ax um, just become objects. And I'm looking, and we're using ax, but we're not using scatter, so I'm not really sure what Mike had in mind there. Going back to that, so it's just a different. It's the same as the Seaborn, but it's calling the native matplotlib one. So we'll see now the difference in a Seaborn LM plot, which is the linear model like we were using before. Same plot, just looks a little different. Because again, SNS sits on top of Seaborn. It seems like, or on Matplotlib, Seaborn sits on top of Matplotlib, and it seems like Seaborn adds more options for doing formatting and whatnot. Makes things prettier, a little simpler too. It seems like Hexbin plot. We talked about that before. It just it's a lot like a scatter diagram, only it bends the result. And this joint plot shows you a histogram, as well as the 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 darker the bin here, the more dots were in that zone of the hex plot. But just another way to look at two different variables and how they relate. And then here's a Seaborn box and whisper. Box. Again, we're using AX, not box. And that way we're looking side by side at the average total bill, which is our y-axis, split out by lunch and dinner. Of course, just like you'd think, your average dinner bill is higher, and a little bit more of a spread. A lot of time lunch is just one person coming in grabbing lunch, just like you'd think. Okay, and then pairwise relations. Pair plot. So this looks at a data frame. Pair plot, it goes in and matches every continuous variable against every other continuous variable and creates you this nice matrix. In the center, where like total bill and total bill intersect in this upper left hand corner, you can't do bivariate analysis on one variable, so they just go ahead, they just give you a histogram of that one variable and put that in the subplot of this figure. And then they see some of these are almost categorical. So that like the party size almost looks like a categorical variable because it's numeric like that, but it's technically not categorical, it's numerical. So you get these straight lines of data, as opposed to tip, which has got a lot more variation, tip to total bill. So that's how that one works. A pair plot. That's for looking at all of your stuff at once. If you just give it an entire data frame of data to look at. let's see this next thing. Assign custom plots to different parts of a pair plot. So that's by default what you get, but you can designate in different regions of the figure to do different things. And of course, here we're going to get a warning because dist plot is being deprecated. Future warning. So that's here we're reg plot is a regression plot. KDE plot is a kernel density estimate plot, which looks a lot like it's a lot like a scatter diagram, but it shows the density in these weird concentric shapes. and it can even like identify like an outlier. Like you see how you got this bubble in the lower left hand corner sticking up there. It's I had not heard of it before a couple of years ago. Kernel density estimate plot against multivariate data. It's the same concept as that smooth line over the histogram, but this is the I guess the same technique applied to bivariate data. And then of course we're doing dist plots, which are just scatter diagrams, scatter plots. And then just like we were saying before, we can add the hue parameter. As with my possible ways to include more information and distinguish data. Now I had, yeah, we're going to get a error. You're going to get an error, not on this cell, but in a couple of cells here. So here's a scatter linear model plot with an X value along the bottom, tip going up the Y-axis. We're splitting it using the hue parameter by sex. The data frame is tips, and fit regular expression, true. Fit regression. Fit regression. There you go. Is true. So we're fitting a regression line to those two. Very similar, the line, so that's showing you that the correlation between total bill and tip, there's not a big difference between men and women, which good. I would hate to think, here comes another guy. He's not going to tip me. So that's how that one works. And then pass a hue into a pair plot. I can't remember what this one does. Okay. Total bill, tip, and size. But, oh, yeah, cool. So we're doing a pair plot on the tips data frame, which is the first parameter. And you can leave off hue equals sex. But if you put it in there, that's cool. It gives you all of that data broken down by the categorical variable sex. Pretty cool. And I don't know. I think it might be easier to do this in Python than it is in Excel. I guess if you know it's on how strong how familiar how strong you are with each tool. But adding different variables like this, once you get rolling and you're using this stuff, it seems to be pretty easy in Python. But so here in this next one, what we're trying to do is vary the size of the dot in a scatter plot based on a variable. This scatter underscore KWS is a matplotlib parameter that you can put in your lmplot command, and it changes the size of the markers of the dots, and you have to it gets kind of complicated because you got to pass it a dictionary of values. And in your notebook, it says scatter KWS equals this S:10, but before the colon, um, it was using tips size times 10. So it was trying um, to use like a calculated field to grow the size of the marker when the size of the party increased. But size times 10, I think it made it too big because when y'all run it, it's going to error and tell you it has to be a value within the range of something or other. And I couldn't get it. I couldn't figure out what was erroring. So I just took out the complexity of the data frame size column times 10 and just put 10, just the numeral 10. So I'm forcing the size of the markers in the scatter plot to 10, which is kind of small. So if let's make that say 20 and see what we get. Bigger, you can start to see them now. So yeah, you got an asterisk makes an asterisk, a P apparently makes a dot, and these code characters are all in the documentation. You got to go look at what the legal values are to get it to do something different. But it's bugging me that it wouldn't. I could not get it to work. Um, it shouldn't be that big. I'm curious if I 1006. Yeah, I'm good. If I put that back in, I just commented it out and moved it there so I wouldn't lose it. So if I say, and the times, and it seemed like it had 10 before. Maybe that's too big. Just like times 2 and see what I get here. If it Nope, same thing. There's something about using this calculated field on this side of the dictionary that is confusing Seaborn, and I could not figure it out. I didn't spend hours trying to figure it out, but I did spend minutes. Must be a scalar or float array like with the same size as X and Y. But the numeral 10 works. Anyway, if any of y'all figure that out, please let me know. I looked at it for, I don't know, 20, 30 minutes, couldn't figure it out. Then what else we got here? Getting down to the end here. One more. The Anscombe plots in Seaborn. Oh yeah, we're just recreating that 4-plot grid using Seaborn instead of Matplotlib. And you can see same exact result. But again, the LM plot is a figure, and then each of the individual plots inside subplots are axis level, like and you can specify when you're dealing with an LM plot, the column isn't necessary. The column is like each of these subplots is in an XY grid, and you can start to mess with column and row that way. So that's some Seaborn examples. And again, I found a lot of merit in that Seaborn tutorial that I found on GitHub. Okay, 1008. Let's take a long one. Let's take 20 and come back at 10:30, and then I'll go over. In the interim, if you would go to the classroom. Let me make sure I published it. Here we go. In the classroom Python section, download my Python data analysis project. No, I'm sorry. Wait a minute. That's the assignment itself. Example exploratory data analysis. That's my notebook where I went in and just had tons of fun goofing around with Seaborn data sets. So download that, get ready to take a look at it when we come back at 30 after. Any questions? You guys are too easy on me.
Not.
Okay. All right. We'll come back at half past the hour, and I'll show you an extensive version of what I'm looking for. You guys, I'd turn in something much simpler. See you back in 20.
Okay.
Welcome back to hour 2. So um, I want to show you a sample exploratory data analysis project. This is, not real world, but um, something I did just for example's sake. So I just want to be really clear. I'm going to ask you to present um, on Tuesday during the third and fourth hours of class. This won't be something that you just turn in. So everybody will have a go at getting their microphone rolling and talking through a Jupyter notebook, just as I'm about to now. And again, uh, absolutely doesn't have to be as extensive, looking at as many variables or using as many plots as I did, or even enhancing an initial data frame with an additional column like I did. Um, it can be much simpler. Um, just as long as you got something to show for, because I'm giving you back probably about 4 hours to do it. So yeah, this worked out pretty well last time. So I'm hoping you enjoy. It's just a chance to freeform play with play with Python, doing some data analysis on a file you already have that you haven't looked at in Python yet. Or you can use a Seaborn data set like I did here, and I enhanced it with something I grabbed off the internet just for example's sake. So without further ado, um, this is what I'm looking for. So here is the notebook that I posted on the live on the classroom out there. And again, like I said, I developed this back June of last year, kind of as a capstone for what we covered in Python, um, which we devoted a lot of time to. So I hope you enjoy this exercise. I like goofing around with it. I just have fun. I guess I'm a sad, sick person that actually has fun playing around with computer code, but I love it. Uh, so we're going to import Seaborn Pandas and Matplotlib. And I went through this. I don't believe I have any errors. I might have a deprecated message, but so I opened up those libraries, and then in this next code, I just wanted to. You don't have to do this, but I just wanted to show examples of going through those Seaborn data sets and looking at them to give you a little bit more of an idea of what's available out there. So get data set names returns a list of the names of the data sets and puts it in this variable data sets. And then we can for loop for I in data sets. So now I will be equal to each data set name. So in here, I load each data set to a data frame so that I can then do a df.head. And that's all I'm doing, printing out the name of the data set and a df.head so you can kind of get an idea of what's in all the what is in all these data sets. And this is how I literally, this is how I decided I had some interest in one of these Seaborn data sets so that I did the rest of this project on it. So we got I don't even know what anagrams, we got the Anscombe data set that we've dealt with. Again, these are all you can Google what these data sets are, and in the next couple of markdown cells, I provided the description of the one I wound up using, but they're all documented out there on the internet as to what they are. Yeah, brain networks. Yeah, that one. I was like, don't think I want to mess around with that. I don't think I want to play with that at all. And then I ran into this car crashes, which looked interesting. It's got car crash data for 50 states, which I thought would be straightforward to work with. What the number uh, that had speeding involved, alcohol involved, uh, specifically designating if they were not distracted and if they were clean drivers. And then we look at the insurance premium and losses by that state. So I thought that was pretty interesting. I had done one of the students did one on this diamonds, which is just a bunch of raw data about individual diamonds. I don't know anything about dots. I think this was an exercise log. Here we have, um, I think it's passenger data um, by month and year for the airline industry. There's one down here. Some of these are scientific. I have no idea. Duration waiting on geyser data. You see this iris data a lot you being used in tutorials. This is observations of iris flowers and their sepia and petal sizes, and then which subspecies of iris they are. So you see people doing a lot of like you know bivariate data analysis using the iris data set. Um, yeah, we've got cars and their miles per gallon. I know somebody used this one last time. That's an interesting one. Penguins. I do a lot of stuff with this penguins. This is the one that shows, bill length. I've used this before I think in the intro to pandas. Um, so it's the observations of three different penguin species on, I think, three different islands in the Antarctic, and their biometric data. Okay, so that was just an example of plowing through some data, looking for something interesting to play with. So on this one here, I defined, kind of formally, and again, you guys don't have to be this formal. You know, sort of like a justification for this analysis, kind of like if you were doing this for your class project, for your final project, and you were using Jupyter Notebook. So I put a blurb in here about why I'm looking at crash data, because it's such a major cause of death and whatnot. So that's what I'm working with is the car crashes data set. And again, this is the data I'm using. This is my notebook. It's just an example. Um, you know, use it as a rough guide for what to present on Tuesday. But again, it's really just fun goofing around. If you pull in something that you just think is fun, like, I don't know, if you're into basketball or Arkansas Razorbacks historical win-loss data or whatever you want to play around with, that's fine. Just kind of follow these steps. So, dry. Of course, first step, gathering data and understanding it. So, in my notebook, I created a data frame called DF, because that's what you call a data frame, out of that car crash data, and printed out all the rows, actually, 60 rows, and it's one for each state. So there you go. And the data dictionary I found online, and this tells you the column and what it really meant. I believe I got this from the actual GitHub repository that stores the car crashes data. Okay, so that's gathering and understanding data. I had to do a little bit of wrangling. There's a DC column in there, and I didn't have DC data for. I wanted to add some additional data, and it did not have DC. Where's DC? There it is. So I could tell when I went from 0 to 50, I knew I had one too many in there. I wasn't sure what it would be, Puerto Rico or DC or something else. But sure enough, it was DC. So I say data frame equals data frame, where data frame abbreviation is not equal to DC. So I'm extracting that row basically. And when you run it again, you see that DC is no longer. You go from 0 to, now hang on, what did I miss? What did I screw up? 0 to 50 means it's still in there. Did I miss my in place equal true or something? Or no, the df equal command should have done it. Why? Somebody come off microphone and talk me out of my tree here. Why am I still going from 0 to 50? I looked at this last night. I spent quite a bit of time with this. Is there another one? Arkansas, okay. Iowa's out of order. That's weird. I'm looking for an additional state that isn't right. That looks right, but it should be 0 to 49. Anybody?
Is it because it's starting at 0?
Well, no, it
And
should
it's
go
just
0 to
long?
49 for 50 states.
Yeah.
And I looked at this. I'm wondering, another data set I had actually had Iowa as IO, not IA. So I had to correct that. But I'm looking for like duplicated states, or does anybody see like PR for Puerto Rico? I could have swore this one was fine with just, anybody see a state duplicated or a weird code that's not a state? Oklahoma, Oregon, Pennsylvania, Rhode Island, South Carolina, South Dakota, Tennessee, Texas, Utah, Vermont, Virginia, Washington, West Virginia, Wisconsin, Wyoming. Uh, from 0, Alaska, Alabama is 0, and we have a row 50. I did not notice this last night. This is freaking me out. Anybody?
I didn't see a line 8. Can you go back up to line 5 and 6?
Yeah.
Oh, that's what it is. Yeah. Okay. That's what it is. When I got rid of DC, it was at position 8. Thank you. So we're indexing by this numeric, but luckily we're not using it for anything. And the quick fix for that is to just re-index it. And it starts again and reassigns those 0 through, what do you call it? Okay. Thank you, guys. Mystery solved. Who gets the Scooby snack for that one? Was that Paul? Dave? Who said that?
I think it was Dave.
Way to go, Dave. So so this will fix that, this next command, I believe. Iowa looks out of alphabetical order, could be others. Just to be sure, we'll sort the data frame by state code and re-index it. So when we execute that, Iowa is at the beginning of the I's, like we would think. Number 8 is back in as our used index, and we go from 0 to 49. There we go. Okay, so I wanted to enhance that data. There's one of the bubbles in our little wheel of analytical pain, our process diagram that says enhancing data. So sometimes you've got data, but you need to go out and add a little bit more. So I thought, what the heck? Let's bring in some age data to our data frame. So I've got and I posted this in the classroom along with this exercise, US state median age.csv, and I've got that up in my data directory. So I'm reading that in to a data frame called median age df, and then I'm just to be sure, I'm sorting the values based on the state field, and saving it with my in place equals true. And resetting the index and looking at it just to make sure that everything lines up. Remember, that's one thing I failed to emphasize when we were before we did the data wrangling exercise or that last exercise. So this one is sorted A through or Alaska through I'm sorry, Alabama through Wyoming, 0 through 49, and we've got some age data here for each of those states. And because it's just an example, I did some clean through unnecessary data. So I wasn't gonna, I didn't want to break out things by gender. So this next cell just drops those columns off of the median age data frame. Do that, and then print it out again just to make sure everything's copacetic. So we got the first 50 rows of our original main data frame. Scroll up a little bit, and then 50 rows of our insurance losses, and they both go from HIJKL. Yeah, Alaska. Oh, ha! This 2-digit state code comes first, but in the song, Alabama comes first. Alabama, Alaska, Arizona, Arkansas. Anybody else have to memorize that when you were in elementary school? I knew it at one point in time. Don't remember that one?
Nope.
Yeah, if you're ever in like a trivia contest and it's like, how many states start with I or whatever, if you know that song, you can sing it really fast. Alabama, Alaska, Arizona, Arkansas, California, Colorado, Connecticut, Delaware. Y'all didn't have to sing that one, huh? Well, you probably didn't play Duck Duck Goose either, for that matter. Tell us about the old days, Don, before the internet, when you played Duck Duck Goose and sang the state song. So yeah, our median age, I dropped those 2 columns I didn't want. And again, we're still indexing. I haven't set the index to the 2-digit state code. It's still numeric, 0 through 49, both Alaska to Wyoming. So that all looks nice and lined up so that when we join the data frames, it'll be all nice and lined up. So here is another data frame joining method, PD concat. I think we did PD.join, and then you can just say, a data frame column equals another data frame column. There's lots of ways to goof with this data. So I concated, and you pass it a list of data frames. Tell it axis equals 1 means you're doing columns, not rows, and sort equal true. And then we look at, so crash DF will now be our original data frame combined with the age data that I added. And there it is. And it's nice to verify, since they both had 2-digit C code, you can go down here and in order and say, yeah, okay, it looks like it all concatenated appropriately. But now we've got two state names, Abrev and state. Don't need both of those. So I'm doing a little more data scrubbing by getting rid of abbreviation. And again, you guys, I mean, this is taking, a half an hour to go through. Y'all do something you can run through in 5-10 minutes and we'll be golden. So no need to go through all this agonize, but I wanted to give you extra, I wanted to give you coding examples too. So this notebook is dual purpose. Okay, so begin analyzing data. So sorting is like the first thing you can do with a data set to kind of look at the data. What's the most of something? What's the least of something? So I sorted our data frame and looked at total accidents, and that is total per billion miles driven. Remember, up in our data dictionary, it's a relative term, like like per capita, total number per billion miles, total number of drivers in fatal collisions per billion miles. And yeah, and this data is kind of old, but it's just an example back in 2012. So it is a relative estimate. It's not an absolute count. That's what I did. And I looked at it. And so apparently Massachusetts has the least amount of crashes or fatal, or at least a number of drivers per fatal accident. I guess that equates, beg your pardon, to safest. Um, and then I wanted to know where we were. It seems like we're middle of the pack here. No, we're way down at the end. Yeah. Lots of accidents per billion miles. So I don't know if that's hills or if there's anything in common with these. That's more advanced, data science analysis we could do to find commonalities between those states and um, why you get so many fatal uh, numbers of drivers per billion miles, fatal accidents per billion miles. And then I thought, well, interesting. Since we're exploring this data, let's look at the cost of insuring a car. So insurance premiums, the average premium, uh, this data, and we'll see it in a minute, is really skewed. There are some really expensive states, and then it gets more reasonable. And this was another one I wanted to say we weren't too terrible at. Yeah, we're up here at 827 compared to New Jersey, 1300. So so we'll correlate these later. So I wanted to look at create a calculated field. So I'm calling insurance profit the difference between premiums and losses. And I thought that might be illuminating. So I created that, and then I sorted by insurance profit, my new field, and I print off the state and just the insurance profit. And sure enough, New Jersey is the most profitable, that happens to charge the largest fee. And again, where's good old Arkansas? Yeah, middle of the pack, 684. And again, this data is really skewed. These big numbers at the top draw the histogram over to the left quite a bit. So yeah, insurance profitability seems to be pretty high up there. So good grief, why is New Jersey getting so much profit per insurance person? So to look at things, I'm drawing a few plots, like I said, just exploring, just kind of combing through the data and seeing what I find. So here's our histogram of total, and it's pretty normal looking. And again, dist plot, yeah, future warning, dist plot's gonna. But I wanted to look at all of the variables to kind of see what might jump out as a correlation that I was or was not expecting. So I ran pair plot, which, remember, looks at every continuous variable in a data frame. Crash DF is our data frame. Pair plot is our seaborne visualization that, with no other parameters, just throws up a scatter diagram of every continuous variable in the data set. So this is hard to see on Zoom, but hopefully you're running this along with me. It takes a minute to render, 30 seconds or so. There we go. So now we get, I just showed these last hour. We did a pair plot on that TIPS data set last time, which was just a few variables. Well, now we're looking at what, 1, 2, 3, 4, 5, 6, 7, 8, 9 variables, 9 times 9, 81 subplots. So it starts to get, but you can see just looking that some of these obviously correlate, and some of them that look like a Rorschach ink blot test don't don't correlate at all. And if you look at them, you can kind of think um, that they should or shouldn't correlate. I looked at a couple here that don't correlate well. Um, so I wanted to look at an individual scatter plot of that pair of data. And insurance company losses don't seem to relate to fatal accident totals. And that is reflected in this, I believe. Profit and total is the upper right-hand corner. And I was thinking for sure that the total accidents per billion miles, uh, if it was lower, they'd be more profitable or maybe less profitable. There would be some correlation, but there is virtually nothing. So you look at it and I don't know. Again, I'm not in the insurance business. And then it looked to me that premiums don't seem to relate to deaths. I don't know. It could relate to other factors. There's a lot of other factors out there. Insurance premiums could relate to the cost of labor to repair accidents, the availability of body shops, or whatever the case may be. The number of fender benders versus totals. I mean, there's all kinds of different factors, but those don't seem to relate at all. And the scatter plot does a really good job of showing that thing. However, I think you can see inside the pair plot, people that are drinking tend to be speeding. So that's a pretty tight relationship there. Speed and alcohol correlate, and correlate positively. It's every once in a while you'll see somebody on cops pull over somebody going 4 miles an hour with their door open, trying to get home when they're toasted. And that's apparently not the case according to this data set. Speeding and drinking go hand in hand, as you might think. And then I was looking at these. These are the two measures of goodness of the driving, and they seem to correlate pretty closely. Like someone who was not driving distracted had no previous accidents, so they were like an innocent person that just happened to get in an accident. So yeah, they correlate pretty closely. And then the reason I added median age was to look at total accidents or insurance premiums or whatever based on age, because they always charge you more when you're younger. So I ran that plot, see what we had. It looks like there may be some correlation. As the median age increases, the total number of wrecks per billion mile does decrease. If you look at the regression line, there is a relationship, but when you do the correlation matrix, or the correlation score, it's not so good. And I looked in not that you guys have been necessarily worried about this as I have, but I looked in the documentation. I could not tell if it's returning R or R squared. I assumed it was returning R squared because I was looking at some correlation values that I thought were always positive, but it may have just been that the data was positive. It looks now, upon further review, that the core method that I'm calling here to correlate median age and total returns R. So it will be negative in this case. And the Kendall, learned a little bit about this last night. The Kendall correlation coefficient is kind of like Pearson's correlation coefficient, only Kendall will correlate. It's a number between -1 and 1, just like Pearson. But it will fit curvy data and show a 1, where Pearson looks for a linear correlation. Kendall will pick up like a logistic regression and whatnot. At least that's the best as I could tell. So I went ahead and forced it in there. I think it defaults to Pearson, actually. And yeah, -0.16 is a weak negative correlation. So there you go. Interpret and report results. Back to the question at hand. Why is New Jersey so expensive or so profitable? So I wanted to look at factors of the least and most profitable, New Jersey versus Iowa. And just kind of breezing through it. Alcohol's similar, age is sort of similar. The total was lower in New Jersey, but they're more profitable. The total in Iowa is higher. Um, Insurance profit in Iowa, super low. Insurance profit in New Jersey, super high. So I could not find a definitive rhyme or reason other than premiums. If we go back to the scatter plot, insurance premium and insurance profit are, here's premium and profit. So bottom row, 1, 2, 3, 4, 5, sixth cell, insurance premium and insurance profit are just tight as can be. So you charge more, you make more. I thought, I sure was expecting to find something more interesting, but sometimes you don't. So, and again, I was looking at age, and the correlation for that, if insurance premiums, not correlated, 0.09 is quite low. So it's not like the average age of folks causes insurance to be noticeably or definitively higher. So anyway, I thought I had a lot of fun doing this and just going in and freeforming and not trying to solve, a particular puzzle like all the other exercises we've done. I've asked you to do a specific query or a specific Python task or whatever. This one's freeform. So so go nuts. Use a work file. You can use just one CSV if you want. Draw a couple of charts. But let's all reconvene on Tuesday at 10:30 Central, 10:30 y'all's time, 11:30 my time. And we'll go around the room and play show and tell with a notebook, just like I did right here. And you're welcome to use this one and just get rid of my code and get rid of whatever you don't like in a markdown cell. Absolutely welcome to. And you can use a Seaborn data set, or you can use something out of our Excel workbook or our Excel textbook, or something that you find out there on the internet, or you scrape with the get HTML method. Matters not to me. Something that interests you, whether it's professional or personal. But go do a little exploratory data analysis with a data set of your choosing, something that you're going to have fun with, because I want you to work on this for a few hours. Any questions on what I'm looking for and when we're going to reconvene?
I don't believe so.
Okay. I've got my phone turned up, and I'm going to leave the Zoom session up. If any of you need any help and you get an error, especially that you just can't figure out, call me. Probably better to call me than text, because I think I've turned notifications off for texting. Give me a call. Everybody's got my number, right? It's in my signature block in my emails. Give me a call if you need anything, and then I'll turn the Zoom session off at the end of our normal class session. Okay, I'm going to go ahead and stop share and stop record. And y'all get to work and holler at me if you need anything. Anybody need me right now while I'm on? While we're on? Nothing, nobody, nothing. Okay, great. Have fun, guys. Holler if you need me.
Thanks.